Hello, I'm Erdem from Uvision. In this video, I will find power dissipated by this 2 ohm resistor by mesh analysis. The first step is to choose a ground node, and I'm choosing this node to be the ground. Remember, in mesh analysis, choosing ground will never affect your analysis. It's like a tradition, it's always better to have a ground node. Okay, the second step is to assign unknown mesh currents. I'm looking at this node X and I'm seeing that we don't need to assign an unknown mesh current. We have already information about that current, and that is this 3 amperes flowing in clockwise direction. We don't know current flowing around this mesh Y, but it's labeled as IX. Have you realized this? That is IX, and I'm telling that current flowing around this mesh Y is IX. Okay? We don't know current flowing in this mesh Z, and I'm labeling it IZ. We will have 2 KVL equations because we have 2 unknown currents, unknown mesh currents. So let's firstly apply KVL for mesh X. Okay, I'm starting from this point, and first component is this 3 ohm resistor. There are 2 currents affecting on it. First one is IX, second one is IZ. Since our reference direction is to the right and IZ is to the left, we need to subtract IZ from IX and multiply it by 3 to get voltage difference across this 3 ohm resistor. Next component is this 5 ohm resistor, and we will just multiply IX by 5 to get voltage difference across it. Last component of this mesh is independent voltage source. We are entering it from its minus terminal, negative terminal. That's minus 5 in the equation. Please don't get confused with these labelings. This is mesh X, and this is current IX flowing around mesh Y. Okay? And second and the last KVL for mesh Z. I'm starting from this point. First component is this 2 ohm resistor. IZ and 3 amperes is affecting on this at the same time, so we should subtract 3 amperes from IZ because our reference current is IZ. IZ minus 3, multiply this by 2 to get voltage difference across this resistor. Second component of this mesh is this dependent voltage source, and its value depends on current through this 5 ohm resistor. We are entering it from positive terminal, which is plus 4IX in the equation. And last component of this mesh is 3 ohm resistor. IZ and IX is affecting on, IZ and IX are affecting on this one. Our reference current is IZ, so we will subtract IX from IZ. Okay? Multiply this by 3 to get voltage difference, and set whole equal to 0 by KVL. Let's make rearrangements on the equations. And I'm firstly rearranging this KVL for mesh X. I'm labeling it as 1. Okay? I'm writing down every term explicitly. 3IX minus 3IZ, 5IX minus 5 is equal to 0. And here we can find the simplified equation as 8IX minus 3IZ is equal to 5. So easy. Let's rearrange KVL for mesh X. We have 2IZ minus 6, 4IX plus 3iz minus 3ix is equal to 0. Let's sum the same ones up. We have 4, 1. We have 1ix, we have 2 and 5iz, and this is equal to 6. If you do some linear algebra with these two equations, you can find Ix as 1.0465 amperes and Iz as 0.7907 amperes. Alright? I don't remember what I have told you at the beginning of the video about, but for now I want to find power dissipated by this 2 ohm resistor. And firstly, let's find actual current flowing through it. This is the component 2 ohm resistor. This Iz and 3 amperes is affecting on it. Iz is coming like this, 3 amperes is coming like this, right? And you can see that 3 is bigger than 0.70 blah blah blah, and so we need to subtract Iz from 3 amps to get actual current flowing through this 2 ohm resistor. And I'm writing actual current, that is 3 minus 0.7907, and I'm taking this as 0.8, which makes 2.2 amps. This point. So to find power of this resistor, we can multiply I squared by R, and square of 2.2 is 4.84, and resistance is 2 ohms. Multiply them, you can get 9.68 watts. Alright, so power dissipated by this 2 ohm resistor is 9.68 watts. That's all for this video. Thanks for watching.